All right, let's journey together to the very limits of what we can see, to the furthest reaches of space and time. We're going to tackle one of the biggest questions imaginable. What's really at the edge of the universe?
You know, it's a question that people have been asking forever. You look up at that vast, star-filled night sky, and you can't help but wonder, does it all just stop somewhere? Is there a wall at the end of it all?
So, we're diving into the universe's ultimate question. The thing is, in a way, we're kind of trapped. We're imprisoned inside what we call the observable universe. We can only see so far. And what's beyond that point? Well, that is one of the biggest mysteries out there.
Okay, so here's the big idea. The key to this whole thing isn't about finding some kind of physical wall out there in space. The real boundary we're up against is actually a horizon in time.
So, what exactly is the observable universe? Well, think of it this way. It's basically everything whose light has had enough time to travel all the way across the cosmos and finally reach our telescopes here on Earth. It's like we're sitting inside our own personal cosmic bubble of perception.
And this is where it gets really wild. Looking out into space is literally looking back in time. The light from our own sun, it takes 8 minutes to get to us. The light from Proxima Centauri, the next nearest star, that's over a 4-year journey. So yeah, every single thing you see in the night sky is a picture of the past.
Now, we know from studying the oldest light in the universe, that faint afterglow from the Big Bang, that the universe is about 13.8 billion years old. So it seems logical, right? The absolute furthest we could possibly see should be 13.8 billion light years away. Makes sense. Or does it?
But here's where your brain starts to hurt a little. The most distant things we can actually see are not 13.8 billion light years away. They are a mind-boggling 46.5 billion light years away from us right now. Wait, what?
Seriously, how is that even possible? How can something be that far away when the universe is only 13.8 billion years old? It feels like it breaks the laws of physics. But this little paradox, this is actually the secret to figuring out what's really going on. And the answer lies in our expanding universe. It's not that those galaxies were speeding through space faster than light. Nope. The secret is that space itself has been expanding this whole time.
Now, it's super common to think of the Big Bang as some kind of explosion happening in space. But that's not it. The universe isn't expanding into anything because there's no outside for it to expand into.
What's actually happening is that space itself is stretching. The very fabric of reality is expanding, and all the galaxies are just being carried along with it.
Okay, here's the classic analogy, and it's a great one. Imagine you've got a balloon, just a regular balloon. Now draw 2 little dots on it. Those are our galaxies.
Now, as you inflate that balloon, the dots themselves aren't moving on the rubber, right? It's the rubber itself that's stretching, carrying them further apart. And that's exactly what's happening with the universe. A galaxy sent its light our way 13 billion years ago when it was much closer, but in all that time, the space between us has stretched, carrying it all the way out to where it is today, 46.5 billion light years away.
So, let's talk about what's beyond our line of sight. Our so-called edge is just the point where light from the early universe is finally reaching us. But does that mean we're completely blind to whatever's beyond it?
This boundary has a name, the particle horizon. And I want you to really get this. It is not a wall. It's a time limit. It's the limit of what we can see with light. But, and this is a big but, light isn't the only messenger out there in the cosmos.
We're literally developing new senses to explore the universe. There are these tiny, almost ghost-like particles called neutrinos. And then there are gravitational waves, which are actual ripples in the fabric of space-time. The cool thing is, these messengers can travel through stuff that would totally block light, so they carry information from way back, maybe even from beyond our horizon. This is how we might just peek behind that curtain.
This all leads to an infinitely unfolding mystery. The universe itself, it could very well be infinite. It probably doesn't have an edge at all. The only real edge we've found is the edge of our own knowledge.
So here's the big takeaway. The misconception is that there's a physical wall out there. The reality, it's a horizon in time. We think there's an end to existence, but really, it's just a limit to our vision. We're not special, we're not at the center of anything. An alien on a galaxy billions of light years away would have its own observable universe with its own horizon. It's all about perspective.
And this quote just says it perfectly.
We are surrounded by spherical horizons that do not allow distant light to reach us. It really just means the boundary is a natural result of living in a universe that's been expanding for a finite amount of time. It's not a wall, it's just as far as the light has been able to travel to get to us.
So, if the universe has no edge, does our quest for knowledge? That's the real question, isn't it? As we get better at listening to the universe with things like gravitational waves, who knows what we'll discover beyond that horizon? Maybe the only real limit is how curious we're willing to be.
Hey, if you enjoyed this little trip to the edge of everything, do me a favor and like this explainer. And for more deep dives into space, science, and all the big mysteries, make sure to subscribe to Mindscapes by Faizu. Thanks so much for joining me.